ByteBlower, the Xentis cost-efficient traffic generator and analyzer. Welcome to this new tutorial video. In this video, I will show you how to use the new port forwarding view. For a long time already, the ByteBlower GUI offers the possibility to do testing through a network address translation device, or NAT device. ByteBlower can automatically discover how all used addresses and ports are translated before the actual test traffic is started. You can enable this powerful feature simply by setting NAT to yes on the ByteBlower ports located at the private side of your NAT device. But most NAT devices allow you to create specific port forwarding rules. Using port forwarding, you can define how exactly the communication needs to be redirected between one specific address and port number combination to another. The new port forwarding view allows you to create test traffic through devices configured in such way. At the left, you can create new port forwarding items. Each port forwarding item contains a list of port mappings, shown at the right side. The public IPv4 address can still automatically be discovered. This is the default behavior. The discovery will happen by default using one UDP packet on port 1024. But you can change the discovery port and protocol if you want. However, when you already know the public IP address, you can change the public IPv4 configuration to manual and enter the IP address right here. I happen to know that the public IP address in my test setup is 10.8.2.161. In the port mapping table, you can enter all known mappings between private and public port numbers for UDP or TCP. I am currently using a NAT device where the private UDP port 1234 is mapped to the same public port. In the port view, you can now select the port forwarding item in the NAT column. Of course, you can still select yes when you want all address and port translations to be discovered fully automatic. Now, let's send some traffic through the NAT device. I created two flows, sending downstream traffic to two different ports in the private network. While the test is running, you can already monitor the real-time results. And this is what the report looks like. You can now see how exactly all addresses and ports were mapped between the private and public side. Here you can see that the first public IP address was specified manually, while the second one was automatically discovered. You can also see that the first public port was defined in the port mapping list of port forwarding 1, and the second public port was automatically discovered. We hope that you will enjoy using this new feature. Thank you for watching.